Alright, so now I'm going to do a video on asymptotes. So we have a function, 3x cubed divided by x squared minus 25. And the directions are to list all the asymptotes. So we have three different types of asymptotes that we're concerned with in college algebra. The first one is going to be your vertical asymptotes. So for vertical asymptotes is almost going to be the exact same thing as domain. That's why we focus so much on domain. For my classes, by the time we're tested over this, they've already had about 8, 9 questions over domain on tests. They've already had about 30, 40 test points worth of domain. So I'm preparing them as best that I can to make sure when they get to asymptotes, when I say, oh, that's just domain, they're like, oh, awesome, I'm pros at domain by now. They should be pros at domain by now. And so all you're going to do, domain says the denominator cannot equal 0. And what an asymptote is it is a line where the graph is not allowed to touch. So there's this formatting issue that some people like and some people don't. But you're going to say your denominator cannot equal 0. X squared minus 25 cannot equal 0. You can either solve for x, just don't forget if you take a square root, you've got to have a plus or minus. Or you can factor. X squared, 25, that's the difference of squares. X minus 5, x plus 5. Anytime you have something squared minus something squared, it will factor to the square root of the first minus the square root of the second times the square root of the first plus the square root of the second. Right. You can solve these out. If x minus 5 cannot equal 0, x cannot equal 5. If x plus 5 cannot equal 0, x cannot equal negative 5. These are your vertical asymptotes. You've just got to be very careful. Depending on how the question's asked, it could say, what are the equations of the asymptotes? Then it wants the asymptotes. It doesn't want what the line's not equal to. So you use regular equal signs instead of not equal to signs. For me, because I try to emphasize domain so much, if my students answer with the not equal signs, I personally don't care because they knew how to do the process and they know their domain. And I'm trying so hard to get mine to have domain down before they get to pre-calc, before they get to calculus, because you've got to know it there before they start adding all these extra layers on. Kind of like here. If you don't know domain, and then I suddenly change the name of it and I start calling it asymptotes, and then we have different types of asymptotes too. This is just one of the types. It's really going to screw us up because we're going to get stuck on vertical asymptotes, which is domain, which I go through the fastest because I say, oh, that's just domain. We've been doing domain. So you've got to make sure you get these down. The second type that we have, I will make it a little bit higher because it requires a little bit more work, a little bit more writing. Horizontal asymptotes. And if you don't know how to spell asymptote, is it really that big a deal? A, we can learn how to spell it. Or B, a lot of times we just shortcut this to VA and HA. So vertical asymptotes versus horizontal asymptotes. Horizontal asymptotes is one students tend to fight with because it's a long list of things. You've got 3 different cases and you've got to determine which case it is. And depending on which case it is, depends on what the horizontal asymptote is. So it starts with, first thing with horizontal asymptotes you want to do is identify, I want to compare, I'm going to say identify the degree on top and bottom. Identify numerator's degree. Degree means highest exponent. So the highest exponent on the numerator is a 3. Then you're going to identify the denominator's degree. Degree again, highest exponent, that would be a 2. So on top we have a 3, on bottom we have a 2. Then compare. degrees. And depending on how they compare, that's going to depend on what the horizontal asymptote is. So, if they are the same, your horizontal asymptote is going to be y equals leading coefficient divided by leading coefficient. Whatever the first coefficient is, divided by the first coefficient, if the degrees are the same. Now we have 3 and 2. They are not the same. So, first one's not, it's a null point for us. If the degree on top is smaller. If the degree on top is smaller, your horizontal asymptote is y equals 0. Now these y equals are very important, just like these x equals are very important. We can't lose them. Okay, but is our numerator's degree smaller? No. If degree on top is larger, horizontal asymptote, there isn't one. And the way I explain this to my students, I'm a mom, I have an amazing 3-year-old daughter, and I use her to help explain these. When I think about something that's being the same, being bigger, being smaller, I think of people. So you get me and my husband and my daughter. My husband and I are roughly the same size. If I were to climb up on his shoulders, say like playing chicken in a pool, that's okay. No one causes any problems, right? If the degree on top is smaller, that's like if we're walking around the mall and I've got my daughter sitting on my shoulders. She's on top, right? She's smaller, that's okay, right? How many issues are there? There's 0 issues. Now say we're walking around that same mall and I try to climb on top of my daughter's shoulders. My 100 and something pounds, 100 and something pounds, on top of her 30. Are we going to let that happen? I surely hope not. I surely hope someone's going to call the cops. Someone should tackle me. Someone should send my butt to jail if I'm trying to climb on top of my daughter's shoulders. Because she's not going to survive that. We cannot let that happen. There isn't one. It's not going to happen. Same thing here. My daughter has her other best friends. They're about the same size. They're only 3 months apart. If they're climbing all over each other and they're rolling around and they're playing, that's okay. But if she's doing that with an adult and they're rolling around and playing and she's on top of the adult, that's fine. They're just playing. But as soon as the adult gets on top of her, there's a problem. Shouldn't let it happen. Call the cops, right? Make sure if they're the same, well, just take coefficient divided by coefficient. Both of them have a say. If their top one is smaller, y equals 0, no problems at all. If the top one's larger, big deal, red flags, 911. We can't let that happen. So there isn't a horizontal asymptote. Okay, so for this one, top is larger, so we can't let that happen. No horizontal asymptote. Okay. And there's a third type. Let's see how much board space do I have left. All right, so the third type, and I'm running out of room. I'm going to have to erase verticals, I guess. I'm going to put it up here. Vertical asymptote, x cannot equal plus or minus 5. Oblique asymptotes. Oblique means slanted. So we have the horizontal, we have the vertical, and if it's at any other angle but horizontal vertical, that means it must be slanted. So that's going to be your obliques. The way you're going to do oblique asymptotes is you're going to do division. You're going to divide top divided by bottom. If the denominator, leading coefficient's 1, and the degree is 1, you can do synthetic division. If it's not, case in point, you've got to do long division. Okay? So here we're going to end up doing long division. So I'm going to erase the horizontal asymptotes so that I have room to do the long division, just so y'all can see it. So vertical asymptotes was x equals plus or minus 5. There are no horizontal asymptotes. Before we do long division, I forgot there's one rule to this. Degree on top must be exactly 1 more than the bottom. So 3 and 2, right? Those are my 2 degrees. Is the top 1 more? Yes. If it was 4 and 2, then we'd say there's no obliques. This must be your rule. Division only if the degree on top is exactly 1 more than the bottom. So for long division, numerator goes inside. Denominator goes outside. Problem we have, we're missing pieces. So on the inside we have 3x cubed. I need an x squared, I need an x, I need a constant, just like if I were doing synthetic. I need plus 0x squared plus 0x plus 0. I haven't changed the value of the problem, but I need something holding every place. Same thing over here. I need an x. X squared plus 0x, that was a minus 25. Okay? And then with long division, I have another video about synthetic division, comparing it to long division. That goes through the steps of long division a little bit more detailed. So please refer to that one. I'm just afraid of how long this one's getting. 3x cubed divided by x squared. Your first step's divide. 3x cubed divided by x squared. That's going to be 3x. Just 3x, right? 3 on top, 2 on bottom, only 1 left. 3x. Then we're going to multiply, take the top times the outside, x squared plus 0x minus 25. 3x times x squared. 3x times 0x. 0x, that would be squared, right? And 3x times negative 25. These go under here. Make sure you're keeping the exponents lined up. So 3x cubed goes under 3x cubed. 0x squared goes under 0x squared. 75x goes under 0x. Okay. Next step is to subtract each column. So I'm going to subtract the first one. 3x cubed minus 3x cubed goes away as it should. Subtract the next one. 0x squared minus positive 0x squared. 0 minus 0 is 0. And subtract the last one. 0x minus 75x is a negative 75x. Bring down so that you can repeat. If you bring down, you must repeat. Divide. So I'm going to erase my scratch work over here. I always try to do scratch work over here because it keeps me focused on the little pieces rather than getting overwhelmed with the entire thing. All right, so I'm going to divide first inside, that's a negative 75x, divided by first outside, that's x squared. It's going to reduce to negative 75 over x, right? That goes on top. We really don't want to multiply that, right? So this is a weird case. This is actually going to end up being your remainder. because it has a variable on the bottom. That's why. Because we have now switched to where x has a negative exponent. So we've passed the constant now, where x was 0. Because x is in the denominator, that has pushed it past our constant and makes it part of its remainder. Okay? For oblique asymptotes, your oblique asymptote is going to be y equals q of x. So if this is your remainder, that means r of x is negative 75 over x. Q of x would be the front part. So we had 2 vertical asymptotes, no horizontal, and then we had y equals 3x as our, negative, as our oblique or slanted asymptote, depending on how your instructor refers to it as. So I'm kind of glad y'all got to see this. I didn't actually work this one out, and it's completely to see how that one ended up. So I'm glad y'all got to see this. Saves me a different video lecture, so y'all can see what happens when you get the fraction left over and the x on the bottom.